Welcome to today's deep dive, where we'll be unpacking Fischer-Tropsch synthesis.
Yeah, it's a process that you might have seen in your organic chemistry textbooks.
Definitely.
But we're going to go way beyond the basics here.
Oh, yeah, absolutely.
What's really fascinating about this century-old process is that it's having this huge comeback.
Yeah.
And it's all thanks to nanotechnology and this urgent need for sustainable fuels.
That's right. And for everyone listening out there, we know you guys are all chemistry enthusiasts and material scientists, so this one's for you.
Yeah, definitely. So let's just start with a super quick refresher.
Okay.
Fischer-Tropsch synthesis. It's really all about turning synthesis gas, that mix of carbon monoxide and hydrogen, and turning that into the liquid hydrocarbons that we need for fuel.
Right. And what's so interesting about this is that, this process was developed by... It was Fischer and Tropsch, German chemists, back in the 1920s.
Yeah, way back.
Like 1920.
Yeah, it was all driven by fuel shortages. Yeah, they needed to find a way to make synthetic fuels from coal.
Right. Not exactly a sustainable approach.
Right. Not really by today's standards.
Not really by today's standards. But what's interesting is that now it's being looked at to create clean and sustainable energy.
It is, which is where nanocatalysis comes in.
Yeah.
If we can design these really teeny tiny catalysts that are specialized, we can boost how efficient the Fischer-Tropsch process is and also be selective.
Right.
And that makes it a very good way to make sustainable fuels from things like biomass and even CO2.
Absolutely. And, this is where it gets really interesting for our listeners.
Yeah.
Because we want to push the boundaries of chemistry and material science. So let's really dive into this nano revolution.
Yeah.
What makes these nanocatalysts so special, especially when we're talking about Fischer-Tropsch?
So imagine a normal chemical reaction.
Yeah.
You have a catalyst, and it's got a surface where everything reacts. Reactants turn into products. Now shrink that down to the nanoscale. Now things are measured in billionths of a meter.
Wow.
And you have a ton more surface area for those reactions to happen.
So it's like we're going from a small workshop to a massive factory.
Totally. Thanks to nanotechnology.
Yeah.
And all that extra surface area. It means more activity.
Right.
We get more of those hydrocarbons with less catalyst material.
Right. But it's not all about the size, is it?
No.
What type of metal are we using?
Well, the metal matters a lot.
Yeah.
Different metals have different strengths.
Yeah.
Cobalt is great when you are using natural gas.
Okay.
Iron is really good at handling CO2.
So that's good for sustainability.
Perfect for that.
Okay.
And then there's ruthenium.
Uh-huh.
So ruthenium is the fancy sports car.
Oh, okay.
It's pricey, but super efficient.
Yeah.
And even more importantly, it's highly selective.
So what does that mean?
That means that ruthenium catalysts, you can fine-tune them to produce very specific hydrocarbons, which is super important for making top-notch fuels or even really valuable chemical precursors.
So you're saying that just choosing the right metal can really change the direction of the whole Fischer-Tropsch process?
Yeah, picking the right tool for the right job.
But it's not just picking the metal and that's it, right?
No, not at all.
There's got to be more to it.
One of the big challenges with these nanocatalysts is getting the size right.
The size, okay.
Goldilocks too small and you just get methane.
Right.
Not ideal for liquid fuel, too big, and everything slows down.
Uh-huh.
You really have to find that sweet spot size to get the most of those long-chain hydrocarbons.
So it's amazing that something so small can make such a difference.
It is.
It really shows how important design is when we're talking about nanomaterials.
And it gets even more complex because you also have the support material.
The support material.
That these nanoparticles are sitting on. Things like silica, alumina, titania.
Okay.
Or even fancy stuff like carbon nanotubes.
So I'm picturing in my head, we got these nanoparticles, the stars of the show.
Right.
And they're all sitting on this support material, like little workers on a platform.
Yeah, that's a great way to think about it. So they're not floating around. The support is actually really important.
Yeah.
It anchors the nanoparticles.
Okay.
But it also changes how they work electronically.
Interesting.
Yeah, it's like giving our little nano workers special tools.
So we've got the metal, we've got the size, and we've got this perfect support.
Yep.
What else can we do to make these nanocatalysts even better?
We can push their performance even further.
Yeah.
One way is to add promoters.
Promoters?
Yeah, things like potassium or manganese. They're like performance enhancers.
Okay.
They boost the activity and help the catalyst make the right products.
So it's like giving our little workers an energy drink.
Exactly.
Yeah.
And then there's alloying.
Alloying.
Combining different metals to make a super catalyst.
So like a hybrid.
Yeah. So you could combine cobalt and ruthenium.
Okay.
And you have a catalyst that's both active and really selective.
So you're getting the best of both worlds.
Exactly.
So we're fine-tuning these tiny things.
It's like making art at the atomic level.
And it's all happening on a scale we can't even see.
It's wild.
So how does this all translate to the real world?
You know,
Like, how is Fischer-Tropsch actually being used, and how are nanocatalysts changing things?
okay, so some of the biggest companies in energy are already using this stuff.
Okay.
You've got Sasol in South Africa.
Uh-huh.
They've been using Fischer-Tropsch for decades, turning coal and natural gas into fuel.
And what about Shell?
Yeah, Shell's got that huge plant in Qatar.
Yeah, the Pearl GTL.
Exactly.
Yeah,
That's a
yeah.
perfect example of gas to liquids technology.
Okay.
Straight up Fischer-Tropsch. Take natural gas and boom, high quality fuel.
So as we move towards more sustainable sources,
Yeah.
what about biomass to liquids?
BTL is becoming a really big deal.
Right, so taking biomass, agricultural stuff,
Yeah, things we used to just throw away.
right, and we're turning it into fuel.
All thanks to Fischer-Tropsch and those nanocatalysts.
So this process that started because of fuel shortages is now helping to fight climate change
That's pretty amazing.
and create sustainable energy. But of course, no technology is perfect.
No.
So what are some of the challenges that researchers are facing?
Well, one of the biggest is what we call catalyst deactivation.
Deactivation, go.
Over time, the catalyst gets less effective
Okay.
because those active sites on the surface get blocked or changed.
So it's like our factory floor is getting all jammed up.
That's a great way to put it. And
Yeah.
there are a few ways this can happen.
Okay.
There's sintering, where the nanoparticles clump together,
Okay.
which reduces their surface area.
So less space to work.
Right.
Yeah.
Then you've got coking. Carbon builds up on the surface
Okay.
and blocks those active sites.
Like gumming up the works.
Exactly.
Yeah.
And the last one is poisoning.
Poisoning.
Yeah, where impurities in the feedstock
Okay.
basically
But-
damage the catalyst.
Oh, so parts of the factory just shut down.
Pretty much.
So we need to keep these nanocatalysts in good shape
Yeah,
so they can do their job.
for sure. So researchers are looking at different ways to make them last longer.
Yeah.
One way is to come up with better support materials.
Okay, so like giving them a stronger foundation.
Exactly.
Yeah.
And then you've got the hunt for completely new catalyst formulas, trying out different metals, different promoters, different support materials.
Yeah.
It's like coming up with a new recipe.
Okay.
And then we've got all these awesome characterization techniques
Right.
like electron microscopy, spectroscopy, things that let us see what's happening in the nano world.
So like a super powerful microscope.
Yeah, so we can watch how the catalysts change over time.
But even with the best catalyst,
Yeah.
what about those impurities you were talking about?
Yeah, that's where you got to pre-treat the feedstock.
So clean up the raw materials before they go in.
Exactly. It's all about quality control.
But what about sustainability?
Ah, yes.
Yeah.
Well, one of the most exciting areas is using green hydrogen.
Green hydrogen. Okay.
So imagine using solar power to split water,
Okay.
and then you use that hydrogen for the Fischer-Tropsch process.
That's incredible.
It's a game changer.
That's like the ultimate renewable fuel.
It is.
Wow.
Green hydrogen has the potential to make Fischer-Tropsch truly sustainable.
It's amazing how far we've come with this process.
It is.
But it's not just about fuel.
No, there's so much more.
Okay. Yeah.
You can use Fischer-Tropsch to make all kinds of hydrocarbons.
Right. Okay.
So not just for fuel.
Okay.
They can be building blocks for all kinds of things, plastics, cosmetics,
Wow.
even lubricants.
So we can move away from a petroleum-based economy
That's the idea.
and use renewable resources to make those essential chemicals and materials.
It's all about creating a circular economy
Yeah.
where waste is valuable.
So Fischer-Tropsch is like a platform technology.
Yeah, it's got so much potential.
Yeah. It's pretty amazing. But let's go back to the history for a second.
Okay.
You said it was developed because of fuel shortages in the 1920s.
Yeah, back then they needed a new source of fuel,
Yeah.
especially in wartime or when they couldn't get oil.
So they used coal.
Coal was everywhere in Germany. It was the obvious choice.
And it's interesting how those discoveries
Yeah.
are now driving this push for clean energy.
It's like their work had a whole new meaning.
It's pretty amazing.
It is.
But for everyone listening,
Yeah.
how does this affect their daily lives?
Well, the fuel you put in your car,
Yeah.
it might be made from plants, thanks to Fischer-Tropsch.
Wow.
and those nanocatalysts.
That's crazy.
And it's not just fuel.
Right.
It's also the things we use every day, made from renewable resources.
Yeah, it's really incredible.
It is. It's a big change.
But we're still at the beginning.
Yeah, we're still figuring things out.
You know, it's early days for this tech.
Yeah.
What are some of the challenges for making it work on a large scale?
Well, first, you got to be able to make those nanocatalysts in huge amounts.
Right? We can make them in the lab.
Yeah.
But what about industrial scale?
Yeah, it's a whole other ballgame.
Yeah.
It's like going from a small bakery to a mega factory.
Right.
And then there's the cost.
The cost. Okay.
Some of these nanocatalysts, especially the ones with precious metals.
Yeah, like ruthenium.
Yeah, they're expensive.
Right.
So we need to find a way to make them cheaper without making them worse.
Yeah.
It's a tough balance.
Yeah.
But that's where the creativity comes in. People are working on using cheaper metals.
Right.
Or even no metals at all.
Wow.
Yeah, it's really exciting research.
So what's the future of Fischer-Tropsch?
Well, one area is making even more advanced nanocatalysts.
So even tinier.
Well, we're talking about single atom catalysts.
What?
Yeah, where you control individual atoms on a surface.
Wow, that's mind-blowing.
It is. It opens up so many possibilities.
So you're saying just changing one atom can affect the whole reaction?
Yep. It shows how far we've come with our techniques.
It's like atomic sculpting.
It is.
So what else are researchers working on?
They're also looking at new reaction pathways and conditions,
Okay.
like different temperatures, pressures, even different feedstocks.
Okay.
Some people are even using supercritical fluids.
Supercritical fluids, yeah.
Yeah, you remember those from thermo?
Yeah, vaguely.
Well, they're really cool because they can really speed up reactions
Yeah.
and make things more selective.
That's fascinating.
So you need people from all sorts of fields to make this work.
Yeah, like chemists,
Yeah,
material scientists, engineers,
absolutely.
all working together.
All for a more sustainable future.
It's amazing work, and for those listening who are just starting out in science,
Yeah,
this field is full of opportunities.
it's like a treasure map.
Absolutely.
Wow.
And the great thing is, it's so interdisciplinary.
Totally.
It brings everyone together,
It does.
and it's all about working towards a common goal.
And that goal is a better future for everyone.
Absolutely.
We need clean energy. We need new materials.
Yeah, and they need to be sustainable.
Absolutely.
And as scientists, we need to think about the impact of our work.
Yeah.
How do we make sure these technologies benefit everyone?
That's a big question.
Yeah.
We need to talk to policymakers, industry leaders, even communities, so we can make sure these technologies are developed the right way,
Right.
in a way that's sustainable and fair.
Absolutely.
So everyone has access to clean energy and all the amazing stuff that comes with these advanced materials.
It's not just about what's possible.
No.
It's about what's right.
Exactly. We need to make sure these advancements help humanity,
Yeah.
not the other way around.
Absolutely.
We need to think about ethics every step of the way.
Right. And for all the future scientists and engineers out there,
Yeah,
your work can really change the world.
it can.
So use your knowledge and skills for good.
And make the world a better place.
Absolutely.
To keep exploring Fischer-Tropsch and nanocatalysis, there's still so much to learn.
Yeah. And who knows, maybe you'll be the one to make the next big discovery.
It's an exciting time.
It really is.
Yeah.
Well, thanks for listening to our deep dive today.
Yeah, thanks for joining us.
We hope you found it informative and inspiring.
Yeah, we did too.